Now here's an example of an issue tree applied to an engineering problem. Very briefly I'll talk about the problem. In an aeroplane engine, if it's flying at altitude and the engine goes out, you need to be able to relight the engine without descending down to where the air is thicker. If you're over a pile of mountains, for example, you couldn't descend, so you'd want to be able to relight at altitude. Now this is quite a difficult thing to do, and the question is, here on the left, what influences the relight and light round characteristics of an aeroplane engine? Relight meaning relighting one of the burners, light round meaning that that burner then goes and lights all the other ones, because generally you just have one or maybe two sparks in the whole aeroplane engine. Now there are lots of ways that you can divide this problem up into secondary issues. What we try to do is say, let's divide it up into, let's start at the bottom, the design of the network of the burners in the engine. So in other words, where the various burners are. If we had one there and only another one over here and another one over here somewhere, then that would certainly influence the light round capability of the engine, because a spark over here wouldn't be able to light a burner down there. So there's the design of the network of burners in the engine. Let's go to the top now. There's also, if we look at each individual burner, there's the state of the fuel-air mixture. So in other words, how you're injecting the fuel, how you're injecting the air within each burner. And then finally, there's this idea of you've got to introduce energy to a burner in order to light it. So we're talking now about the spark. So we divide this up into three separate areas. First of all, the design of the network of burners in the engine. Secondly, each individual burner before you put in the spark. And thirdly, the introduction of energy into the via a spark. Now again, going back to the bottom, I think that the design of the network of burners in the engine is probably the easiest thing to think about. So the question is, what aspect of the design of the network of the burners in the engine affects the light round and relight characteristics? Obviously things like the distance between the burners and the order in which they're turned on. Now we look at next at the introduction of energy into the fuel-air mixture. So this is point 3 here. This is the spark, and you've got things like the type of spark, how hot is it, the position of the spark, the energy of the spark, how long, the duration is how long would you keep it on for, and the energy is how much energy would be going into the spark. All these things are things that will affect the relight characteristics of the burner, and the timing is how you time the spark, how many do you do, what spacing do you put between the sparks, and so on. These are all things that you might like to test the influence of. They certainly would all influence the light round and relight characteristics of the engine. So you see, what we've done so far is take this rather open question about what influences the light round characteristics, divided up into three areas. We've looked now in some just fair detail at the first area and the third area, and we've got some quite interesting conclusions. One of them concerning the type of spark we're going to have, the other one looking at the network of burners. And these are various things we might like to investigate in more detail. Now let's return to the top one here, which I've labelled 2, the state of the fuel-air mixture in each burner. This is actually going to be a more complicated area, and again you can divide this a number of ways, but we divided it into properties of the reactants and properties of the aerodynamics. Now let's think about the reactants. You've got two things here. You've got a fuel, such as in this case kerosene, and an oxidant that would normally be the air, although you might want to introduce extra oxygen, for example. Who knows? The point is that here you've got three things, the same for each. You've got the composition of the fuel, its temperature, of the oxidant, it's the composition, the temperature, and its pressure. These are all things that will affect the relight characteristics. The composition, you might like to look at that. You might have just air, but maybe you want to introduce a bit of extra oxygen. Who knows? The temperature, you might want to increase the temperature. The pressure, well, that's going to be fixed by the engine, so you can't do much to change that. But you've got the same sort of thing on the fuel side. You could look at the composition, you can look at the temperature, but again, the pressure you won't be able to change because that's fixed by the engine. So I won't carry on any further, but the point is that we've taken this very open question, we've divided it now into a bunch of things, much smaller questions, that we can look at in more detail. We might decide, for example, that a particularly important thing is going to be the position of the spark, and now we can do some sort of set of experiments on the position of the spark, and what we'd actually probably do is start off by writing down a hypothesis such as the position of the spark is very important for relight characteristics of an aeroplane engine, and do a hypothesis tree based on that hypothesis to try and prove or disprove it.